Hello and welcome to another sorting live code. Today we're going to be talking about merge sort. So merge sort is kind of a divide and conquer algorithm. It divides the input array into two halves, recursively sorts the two halves, then merges the sorted halves back together to form a final sorted array. So it consists of two main steps, the division step and the merge step. So there's two kind of separate concepts that need to be done. In the division step, the algorithm repeatedly divides the input array into two halves until the subarrays are of size 1 or 0, which are already sorted by definition. This process is done recursively by calling the merge sort function on the left and the right subarrays of the original array. In the merge step, the algorithm combines two sorted subarrays into a single sorted array. To do this, it first creates two temporary subarrays, one of each of the original subarrays, and copies the elements to the original subarray into them. Then the algorithm compares the elements of the temporary subarrays one by one, starting from the first element of each subarray, and then copies the smaller element onto the original array. This process is repeated until all of the elements in the temporary subarrays have been merged into the original arrays. So that's the concept of what we're looking at for merge sort. So let's jump on in. Let's share screen and start building this out. Now we've mostly been building our stuff in Java. I did have a little rendition of showing how close the things are, purely because they're fairly generic sorting things that can be realized in almost any programming language you could imagine. So I'm keeping them as generic as I can, so that when we go to build them out in other languages, the same process should apply. So I'm going to make a new class called merge sort.java. Let's make the class. So public class merge sort. So same way we've been making these, we're going to make a public static void. So it's going to be kind of an in-place algorithm as such. So public static void merge sort. Now here's where it gets interesting. We're going to take in an array. We also want a left and a right. So we kind of want to say, yeah, let's have the left side and the right side of this array so that we can kind of conceptually view certain parts of the array. So we want an integer array and also a number for left and a number for right. Let's do a doc string for this method. So let's think, what does it do? In its simplest form, it's sort the given array using the merge sort algorithm. It's as simple as we can get it. That wasn't it. Right, so we want a parameter. So at param, ARR, which is going to be the array to be sorted. Then we want another parameter. This one will be L, which is the starting index of the subarray to be sorted. Then we want a similar one for the end index. So R for the right. The ending index for the sub array to be sorted. Okay, so that's kind of our docs for that Java docs for the thing what we want. So let's try and think about this. We need to say only do a certain set of things if our left is less than our right, because we don't want to kind of verge over them sort of thing. We don't want to kind of swap where we're going. So I could say if the left is less than the right, then do some stuff. So what I kind of want to do is I want like a median point or a middle point. So what I could say is like int mid equals the left plus the right minus left. So that will normalize that stuff. Now divide it by 2. That'll give us around about the middle of the actual array, or at least of the left and right portion of the array. That'll give us the middle portion of that stuff. So now we can go off and sort the first and second halves of it. So recursively sort the first and second half. So we want to do next. So we'll run a merge sort. And we'll run it using the ARR, comma, space, L for the left. Oops. And then instead of the right, I want the median, middle. So we're going to say mid. Okay, so that's the one side. But now we need the other side. So we can do a merge sort, still on the ARR. And all we're doing, we're not really making a new array at this point. All we're doing is we're kind of visualizing part of the array in a different spot. So for this, our left side, we want to be the midpoint plus 1, because we already did to the mid. And then our right can still be our right side. So that'll do those two. Now we want to somehow conceptually merge the two. Yeah, let's say. So here's where we're going to be doing some merge function. That'll be taking the ARR, the left, the mid, and the right. Yeah, as an example. So that kind of be the concept of what we want to call. We haven't wrote that yet, so that's why it's in there. So that's basically it. That's kind of our merging sort of, at least the sorting part or the initial driving functionality of that. Now we need to kind of have the merging part done. So here's where it gets a bit more interesting. So we want, let's just do a sort of a Java doc for that. So for this one, I want it to merge 2 subarrays of the given array. Yep. So merge 2 subarrays of the given array. Let's see. So what parameters we got? We've got the array to be sorted. So let's do that. Yeah. Then we've got the left side, which is a starting index again. So in theory, you could just copy kind of this lot here. Going to be there. We also want a midpoint though, so we'll put another one here. The change that right in that way, just to keep them consistent. Okay, so now we've got the Java docs for this. So let's go and make it. So it's going to be a public static void. It's an in-place algorithm again. Merge. Now, a merge is going to take the ARR. It's going to be an integer array. So let's do that. Int array ARR. Then it's going to take an int of L, an int of M for mid this time, and an int of R for right. Now, this is where it gets a bit, well, merging them together is a little bit more lengthy, and we could do it a few different ways. I don't really want to do any nested arrays. But what I'm happy to do is multiple arrays after each other to do the different steps. And this would be a better way, I think, of explaining the algorithm. It may not be the best way of the final form of a merge, but it should kind of get the point across and be fairly verbose and show you a generic way of merging all of those things together. So first, we want to find the size of the two subarrays to be merged. Yeah. Once we've found those sizes, we can copy the data to temporary arrays. Once we've done that, we need to merge those temporary arrays. So let's break that down a little bit though. We need to initialize some indices of the first and second subarray. Then we want to initialize an index of the merged subarray. Okay. Then we iterate over the iterate while let's say the left index is less than the size of the first sub array. Okay. And the right index is less than the size of the second sub array. Okay, so this is like a while loop. Yeah. Inside that while loop, it goes something like if our left array at the index of our first index, so let's say I, is less than or equal to the right at the index of, I don't know, we'll call it J for the right index. Then we want to set our array to the left at index. So we'll say set the final array at I'm learning IJK at K equal to the element at left in I and increment I at this point. Again, I'm just making up names for these at the moment as we go, just to give a general idea. Otherwise, the next thing I want to do is the other side. So we still want to set the final array, we'll say at K still, equal to the element at right of, and we'll call that j. And then increment j. Increment. Okay, so that's our choices. We're either adding the left one or the right one. So to take a look at these two things, saying is this one or this one bigger? Or if this one's bigger, plonk. Otherwise, if this one's bigger, plonk. And we're just doing that, and we just keep doing that, and you've got two piles of things with some numbers on, and you're like, this one's bigger than this one, so I'll leave that. We'll just put this one on. Then we'll put this one on. Then we'll put and keep checking and keep going. Now, at the end of irrelevant to which one gets done, we still need to increment k in this situation, k being the final array's index. So we still need to do, like here, we need to say, okay, well, now I'll increment k as a final thing. So that's that loop. We've got more loops to do. Got, like, I'd say 2 more loops should do. So we want to kind of copy all the remaining elements of L, if there are any. And we'll also want to copy all the remaining elements of R, or right, if there are any. So we kind of want to deal with those. So we've got this iteration. Now we'll just say, copy the rest of the left elements, if any exist, and then copy the rest of the right elements, if any exist. And that's going to be a couple of loops, like while loops will do fine. Okay, so that's the overall merging thing. So the merging thing feels like it's a little bit more complex than the actual sort itself. The sort's fairly rudimentary and sort of in its use case. So now that we've got all of this down, let's go off and make it. Let's do that. So what did we want to do first? The first thing that we wanted to do was find the size of the 2 subarrays. In fact, I'll put it underneath each of these bits, so we've got sort of reference to what we're doing. So find the size of the 2 subarrays to be merged. For that, we can say int, I don't know, n, but that'd be if we've got one of them. So I'll just put it like n1 equals our midpoint minus our left plus 1. Then int of n2, the other n in this situation, will give me right minus midpoint. So there's my 2 different sizes. Now I need to copy some data for some temporary arrays. So I need to kind of, I've got to make some, I need to make these temporary arrays first, don't I? So let's build these out. So it's an int array of left, int left, either way, and set that equal to a new int of size n1. Same sort of thing for the right, but it's going to be n2, so we can literally copy paste for n2, and instead of left, we'll have right. Okay, so we've now got left and right arrays. Now we want to copy that temporary data, or copy the data to the temporary array. So I'll say for int I is equal to 0, while I is less than n1 I plus plus. Now we can do the copy. So we can say left at I is equal to our array at L, which is the left side, plus I. So it just kind of has an offset of L, and we're incrementing each of the items. Now we need to do the same for the right side, so the other temporary array. So I'm going to literally copy that. It's going to be slight differences, but it doesn't really matter too much. But now for the right, I'll change these I's to J's just to give it some sort of difference. And the N1 is going to turn into an N2. Let's see, and instead of left, it's going to be the right. That's going to be a j. And this time it's going to be a little bit different. We're going to do the midpoint plus 1. Then we're going to add j to that. So now we've got our offset of midpoint plus 1. And then we're incrementing the index of j also. Right, so that will do the copy to temporary areas. Now we need to actually do this merging position. So first we need to initialize indices for the first and second subarrays. They're going to start at 0 again. So int I equals 0, int j equals 0. That keeps it nice and simple. And then we'll say that our third, which is our merged subarray, we'll index that with like a k. We've got ijk, classically. K is equal to 0. Well, actually, no, k should be equal to L at this point. It may be slid over. Right, so now that we've got this sort of thing merging, we need to go off and merge the subarrays. So iterate, well, left index for blah, blah, blah. Basically that is what we're going to do. So I'm not going to do that each little bit inside there. I'm going to do it just underneath that for now. Otherwise, lots of click, move down, do this, do that. It's not really very productive. So while the left index, which is I, is less than n1 at this point, and the right index, which is j, is less than n2, then we can continue going. We need both of those to be true. Now we can say if our left at I is less than or equal to our right at j, then all we need to do is want to say ARR at k is equal to left at I and increment I. Otherwise, so else, we can do the other way around. So we can say ARR at k is equal to the right at index of j and increment j. Now at the end of all these, I want to increment k purely because we do need to kind of add onto the actual index of the sort of merged subarray. So that's that. Now we need to deal with the copying the rest of the left elements if they exist and copying the right elements. Now, this will be fairly similar on both occasions. So I'm just going to make it once and then copy paste refactor. So while I is less than n1, then that means that we have some data to copy on the left elements, in which case we do ARR at k is equal to left at I. Then we increment both the I and the k indices. And that'll copy all those, if there are any and when there are any, until there's none left. Then otherwise, we'll end up with this whole side having some stuff left. It's usually like one left on one of the sides. But just in case, we'll make sure that we've got everything, because it may just be sorted higher than the last one. So now, while j is less than n2, I could have just copied and pasted this to be honest, and just changed those two around. Shall I do that? No, I'll just type it. There's not much to type anyway. ARR at k is going to be set equal to right at j. Can you see the pattern here? And we're going to go j++, and then we'll do, oops, and we'll do k++, and that will increment those two. So look at very similar here. It's either the left one or the right one will have a bunch of stuff. Yeah, so that's the idea there. And that's basically our merge done. Now there's a lot of while loops here. So if you look at this and go, oh my word, this is going to be really bad time complexity. Yeah, not as bad as you'd think. In theory, we have an O of n operation here. Sorry, not here. We have an O of n operation. Sorry. The merge is an O of n operation. Even though there's loads and loads of loops. None of them are nested. Okay. Right. So that's a starting point. But then the sort is actually a divide and conquer logarithmic one. So what we're doing is we're doing the logarithmic one times a linear O of n. So O of n times O of log n equals big O of n log n. So that's the overall. So this is this one time complexity is going to be big O of log n. And then the time complexity of this one is going to be big O of n. Reason being O of 1, O of 1, O of 1, O of 1, O of n, O of n, but they're not nested. O of 1, O of 1, O of 1, O of n, O of n, O of n. So you could say 1, 2, 3, 4, 5, O of 5n. But then we get rid of any multiplicative constants like the 5, and it just turns into O of n. So it's just a linear version. So for our purposes, it is the overall merge sort is going to be a O of n log n. That's the actual thing. Hopefully that makes sense. So now we need to do some driving code to actually make it work and do stuff. So nice thing is we've already got driving code from all these different sorts here. So we can just kind of copy our main function here and rename what sort we're using, because we can use the same data and see how it goes. This is presuming I've done no typos or anything silly away. Let's have a look. Let's move that to be a bit there. That's fine. That's fine. So now this insertion sort can now turn into a merge sort. Well, let's see whether there's any typos or anything crazy going on. So we'll make a new terminal and run Java C. This will give me any errors if there's any compilation errors now. Sorry, merge sort. I've missed a semicolon somewhere. Yeah, as you do. Is it only the one? Yeah. So let's save that. It's quite surprising there's only one semicolon missing, to be honest. Formal argument list differs from the length. Pound int star quad int. Where am I doing that? Oh, I know where I'm doing that. Yeah, sorry about that. So the initial is going to be let's have a look at this. So I need to actually add some stuff here, don't I? Sorry about that. Slightly different. L is going to be the left side, which at this point is going to be 0. R is going to be a dot length, theoretically. Let's see if that works. That should be fine. Let's try that again. That looks good. So now let's do a Java of merge sort. And it didn't sort anything. Yeah, just what you really wanted. What's gone wrong here? Oh, do you reckon I should actually return something here and partition stuff a bit? No, maybe not. No, don't. We need to. We don't need to return it here, do we? You gotta love it when it doesn't work. Yeah. But I starting 0, a dot length. Our first merge sort. So our first, oh, I know what I didn't do. Guess who forgot to uncomment merge? Yeah, so it never merges. That's fine. Sorry about that, guys. Fun times, eh? Let's see what we're doing. What's wrong now? Cannot find symbol M. Did I not give it a symbol M? Did I call it mid? I've called it mid. That's why, because I was talking about it in the sense of M there, wasn't it? Let's just redo that. That's fine. Now it's moaning about something else. Out of bounds for length 10. Oh. Yeah, sorry about that. It's the index, isn't it? It's not the size. So we want the A length -1 as the initial input. Off by 1 bugs. It's great. There we go. Sorry about that. It's quite a few typos and little bugs, but yeah, I think that was mostly due to just copy paste instead of actually typing it. But as you can see, it's always one of those things, especially live code. Right, so now that we've got all the little bugs and stuff took out, I hope everyone was shouting at the screen going, "You've missed this," because that's what it's all about. So we've got 2, 3, 1, 4, 7, 6, 5, 8, 9, 0. And then it turns into 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We now have our next set of things and that sort. There's a very long rigmarole here. There's lots of things, and I did my obligatory typos and fun time missing bits with the copy pasta. Hopefully it was entertaining, and hopefully you learned something. The concept that I wanted to get across was all these concepts and the process of trial and error, process of understanding, planning, executing and reflecting upon what's happened, and bug fixing and going through things. So thanks a lot for watching. It's been awesome. Remember to like, subscribe, and share the videos if you find them useful. It does help with the algorithm. And I'll see you again in the next one. Bye-bye.